Hi, a very good morning to everyone. I would like to first thank the conference for giving me this opportunity to share some of our work and also some of our vision. I'm having this title, AI and 6G, both opportunities and challenges. First, a very quick introduction to the Institute for Infocom Research, or I2R. Basically, we focus on digital technologies, including three areas. AI, which has about 2/3 of our research team. And then the second is communications, and the third is in cybersecurity. So with that, if we look at the three areas, we look at in AI, we both look at AI itself and also the AI in the different domain of applications. And for this, we cover some of the basic research, including, for example, the National Large Language Model Program. We are actually one of the research performers in this research program. And at the same time, we are also looking at generative AI, typing on the multimodality, for example, language, speech, speaker, visual, and also 3D generation. And at the same time, we are also looking at interactive AI and also the application for the 6G networks. And at the same time, for the communications, we are looking at some of the main topics in 6G, including the non-terrestrial network to terrestrial network integration, and also integrated communication and sensing, and net zero communications for sustainability. Certainly, security, trust, and privacy resilience for 6G will be a very important focus area for us. And at the same time, with a very large team in AI, we have also been looking at some of the industrial applications for the digital transformation, in particular, like Industry 5.0, and also robotics and automation, and the secure beyond 5G systems for different vertical areas, for example, transportation, aviation, and of course, satellite communications, etc. With that, I would like to also emphasize that we are very open to collaborate with both the organizations in Singapore and also outside of Singapore. So we really look forward to working with everyone here. Now a very quick recap on the evolution from 5G to 6G. As our earlier speakers today have already mentioned, in 5G, we have enabled mobile Internet of Things, and in 6G, we are looking forward to enabling mobile intelligence. And with that, we are also looking at actually these three worlds of convergence on a real-time basis. The three worlds, of course, will be physical, digital, and human world. And certainly in terms of the performance metrics and the KPIs, we are also extending beyond just the traditional rate or latency and reliability, but also intelligence, resilience, synchronization, and also security. So with that, of course, our earlier speakers have also shared this 6G vision from the IMT 2030 perspective, including both the yield scenarios and also the overarching aspects. From the yield scenarios, indeed, from the triangle, three aspects of the 5G, we have extended to a hexagon. In particular, we have added three new scenarios, including the ubiquitous connectivity, integrated sensing and communications, and also for today's topic, integrated AI and communications on top of the three extended performance from 5G, the immersive communications, massive connectivity, and also the reliable low latency communications. And more importantly, the four overarching aspects, connecting the unconnected, which will include both the unconnected people, but also the unconnected things. For example, those moving on the sea, ships, ship crew, airplanes flying on the sky, and also the passengers on the plane, that we want to have them connected all the time with the consistent experience whenever they are. And of course, sustainability will be a consistent theme when we move forward to our near future. And ubiquitous intelligence will be the enabler for both moving to our next gens of communications, but also enabling the communications for supporting the different vertical sectors. And certainly, security, privacy, and resilience will not be missing. Otherwise, all these services, the large performance enhancements, will not be possible. So if we remap the 6G or the IMT 2030 overarching theme into these simple artifacts, what you can see also, in addition to the 4 overarching aspects, I have also added the vertical applications. Ultimately, when we move to the next generation, we are looking at actually how to enable our 6G or even beyond 6G communication systems and networks to support applications, to support our vision of integrating the 3 worlds convergence. Hence, we will need to look at, actually when we're talking about ubiquitous intelligence, pervasive connectivity, the AI model and also will need to enable and build into our 6G systems and networks in a native manner. And at the same time, our AI model and also the 6G system and network will be there to support the various vertical applications so that we are able to have the capability to drive the economic development. And certainly with this, we will have to look at the data generation, data collection, and also the data consumption in a sustainable manner. And of course, we consume the data to push for the performance, to push for the applications. The computation will be a very important aspect. Do we need to have large models all the time, all the places, at the edge, at the device, and also at the cloud? Or we could look at actually different cases to use large models, and also some other cases we will have to look at comprising the model to a more efficient manner in terms of both the data and also compute. And with that, we are also able to drive the energy consumption efficiency. So with that, I will move to share 3 aspects when we look at compute. The first aspect is actually the compute that should be integrated natively in all the communication layers in the 6G system. And share here, actually, we have a very simple sketch, but more importantly, when we integrate the AI in native layers of all the 7 layers of the 6G systems, we will have to make AI fulfilling these few aspects as I show at the bottom: interoperability, controllability, robustness, and certainly the standardization aspects has already been shared in our first speaker today. And also, the AI and the data computing will have to be efficient so that our energy consumption, our memory management will be on pace with the adoption. As I shared, because we have a large team in the AI from I2R, so we focus actually working with the partners driving some of the vertical applications as I share here, like smart urban applications, transportation, aviation, also maritime applications in particular. And certainly there are also other services, for example, digital healthcare and so on. But when we work with the partners, the issue, the consistent feedback and also the challenge we will need to address together with our collaborators is this transparency of the AI model, the black box versus the white box aspects. Otherwise, if we don't address this, I think our partners, when they adopt it into their solutions and systems, they will be worried and concerned that how are they going to move forward when the AI models evolve? How are they be sure that our AI models will give them this high reliability, maybe beyond 6.9 or 8.9? And with that, there is this consistent theme that we will have to make our AI transparent, interpretable, controllable, and also robust enough so that we are able to deploy them into the critical industrial systems. And certainly, when we consume the data, we will have to make the regulation of the data ownership, the data consumption, and also the IPR. And the model, of course, will have to be efficient so that we can sustain the operations in an energy efficient manner. And certainly, I think this is shown in a different perspective, but also consistent with our earlier speakers, that we will have to look at, building the models appropriately at different cases, different venues, being it in the cloud, in the edge, or in the device, so that we are able to drive the consumption and also the efficiency of the AI model, and also consume the data efficiently. So with that, I'm going to share very quickly two aspects. The first aspect is how are we able to drive the native integration of AI in the 6G or even the current generation of the communication systems and networks. The second aspect is when we drive the adoption of 5G and 6G systems for vertical applications, especially for the real-time applications, how are we able to integrate the AI computing and also the communication networks. The first part is actually a very interesting example that we are looking at addressing the problem of spectrum challenge, moving from one generation to another generation. The consistent theme or challenge will be the spectrum scarcity. And this is still continuing in the 6G, even without WRC 23, as shared by Marvin just now, that the spectrum will still continue to be, segmented. So we will have to look at how are we able to make use of the spectrum efficiently, assess the spectrum efficiently. And of course, with that, how are we able to have a more efficient architecture from the traditional multi-bank of filters, so that we are able to assess the different sub-bands of the spectrum given to the systems, to a more simplified, a single RF architecture that we are able to aggregate depending on the available spectrum flexibly, agilely, that we can actually manage the system on a software-defined manner. And with that, we have looked at actually designing this spectrum aggregation using one single RF chain. And of course, by making use of some of the sparse signal processing mechanisms. And with that, of course, we are also introducing some of the nonlinear behaviors into the circuits. And so to take a shortcut, instead of the traditional approach of modeling the nonlinear characteristics, we just have moved ahead of introducing a deep learning circuit at the receiver chain. And shown here on the left-hand side is actually the circuit, the messy RF board, and also the captured signals without introducing any deep learning circuit in the receiver chain. And you can see the constellation of the 16 QAM, and that is actually the recovered waveform. And then we move to look at actually integrating a RNN model. That is actually still a very simple model because we are concerned about the real-time integration and also complying with the 3GPP return, the ARQ return time delay requirement. So with a simple architecture, you can see that we are able to enhance the error vector magnitude by about 8 dB, and certainly with that, we are able to push the modulation scheme we can support in the circuit by a prototype circuit by a few order. And certainly with this exciting development, we believe there will be a lot more that we can do, even in terms of integrating the AI natively in the transceiver lanes. And I would like to share also, this is indeed realized by complying with the 3GPP time frame, because we have integrated with the internet and also the open core network, so that we are able to realize a Zoom video call on a real-time manner. And the second part is actually specially picked because this is also a collaboration with Southeast University. We have tapped on the lab facilities to run the experimental validation. That is actually a very consistent theme of pushing the power amplifier linearity. And at the same time, we have also moved to look at actually massive MIMO, not only just the linearity of the power amplifiers, but also the crosstalk and also the IQ imbalance. So we look at addressing them so that we are able to tackle, by implementing a neural network architecture, the higher order nonlinearities, so that we are able to further push the linear behavior of the power amplifier and also addressing the other nonlinearity in the RF circuits. And shown here is actually a very simple sketch of the circuit architecture. And as I mentioned, we are very fortunate to collaborate with Southeast University because they have a very comprehensive lab testbed, and we have implemented the proposed architecture and also the scheme as shown here in this testbed. And the performance, again, are very encouraging, as we show here by plotting the error spectrum of the different, the different comparison with our proposed architecture. And certainly, the deep neural network that can be compressed and also integrated into the transceiver chain that is able to give us a good performance edge. And of course, moving forward is how are we going to fabricate into IC or even into a hybrid packaging architecture. And this is something that we are looking forward and also tapping on the collaboration with the Microelectronics Institute and A-Star, our sister RI. And of course, if there are interests to work together, we will be more than welcome to discuss with you. And next, as I shared, I will show a very quick example on integrating AI with the communication network, especially in terms of integrating AI at the edge computing, so that we are able to drive the service aspects to support the vertical use cases. And this example is very interesting because it's a use case in the construction sector. For the reason that we started this discussion with the Housing Development Board of Singapore, that is supporting about 70% of the housing requirement in Singapore. During COVID time, Singapore was very short of the workforce because we rely a lot on the foreign worker support. And then we started looking at how to drive automation and by making use of 5G, robotics, and also drone for a few aspects. The first aspect is actually looking at using these robots, drones that are connected through 5G to look at real-time awareness for real-time quality monitoring, quality control by taking in the 3D scanning from LiDAR, image, and video. So that we are able to correct whatever quality defects timely. The second aspect is actually looking at making use of this real-time fetch data to drive or to enhance the work site safety. And with that, we have actually implemented a few work streams, as you can see here. But more quickly, I think in the interest of time, I'm going to share some of the quick results. And this part is actually just the data collection part. I hope the video is able to show. Oh, no, I don't have the control of the video. Basically, the video should be, if you could help me press the black circle, there is a pause. There is a play button there. Yes, that's right. Thank you. Right, so this is just to show that the data collection is indeed on a real-time basis, which is supported by the current 5G network. And all the data is going to be fetched to the edge that is actually just next to the construction site, and then we are able to do the real-time computing. And in the interest of time, I'm not going to show all the video, but this one. And again, please help click on the play button. Thank you. So this is to show actually the 3D mapping and also all the checking and alarm that we can do on a real-time basis. And why am I showing this, which could be a bit, naive and tedious? This is really to show that we are motivating the use of the large foundational models for the sake of a much higher accuracy and much better performance that could be made possible by the foundational model. And you can see this is actually the 3D LiDAR that are being sent to the edge server that we are able to construct actually the 3D BIM model, which will be used for the real-time quality control and quality check. Right. Then, yeah, please move. Yeah, click to twice. So we are looking at actually the possibility when the ChatGPT was launched to type on the foundational model built on the 3D image from LiDAR sensor and also the image and video to have a much better accuracy in terms of the quality control and also the event detection. And indeed, if you look at the numbers that are shown on the boxes, the foundational model is really able to give us a much better push. And with that, certainly the question will be, how are we able to support all these operations? We know that drone and robots are actually power limited. And then how are we going to distribute the computational tasks, at the three entities, the cloud, the edge, and then also on the device. So this is going to be the continued theme that we are looking for. And so there will be actually a lot of exciting work to move when we drive the applications and also drive the design from 5G to 6G. So just a very quick summary. What has been realized in the use case demo that we have just introduced? We have done the sensing and communications, even though it's not the integrated sensing and communications per our 6G definition, but indeed it is a real-time integration. And of course, the computing and communications have been integrated, but a lot more that can be done. And we have also enabled the zero trust that needs to be there to comply with the critical industrial applications, and certainly the real-time digital twin that has been shown just now. But a lot more, as I said, needs to be done. The first is if we are able to integrate really the sensing and communications by making use of the 5G and 6G signals to support some of the sensing activities, how should that be moved so that we are able to reduce the sensor deployment that is needed in the system? And the second part, as I mentioned, foundational model is promising, but at the same time consuming for both data, energy, and also computing resources. So how are we able to drive the distribution of the load so that we are able to still move a data and model efficient implementation, and certainly the multi-model foundation model construction and also implementation in this kind of applications. And at the same time, the zero trust mechanisms for such machine type communication aspects, and also the human-machine collaboration on a real-time manner. And with that, I would like to conclude by just showing this chart, which is currently our focus areas by looking at the 6G research topics. The first is actually machine as another dominant user, because we actually, there are so powerful operators and also vendors there. We don't think addressing some of the consumer requirements will be our key focus. So the industrial vertical use cases will be actually our more dominant focus, and then addressing the machines as another dominant user will give us a lot of challenging design problems, even in the 6G itself. And certainly software-defined everything in an agile manner, as I shared just now for the spectrum application as one use case, but there are a lot more aspects that need to be addressed, as privacy, security and resilience, and also sustainability. But at the center is actually also fitting today's theme is actually to look at developing AI to drive the performance for both the network and the systems, as well as actually driving the 6G to support the vertical application use scenarios. So with that, I would like to stop here and thank you very much for your attention.